is the outline of my presentation for today. So I will be talking about horizontal line test and also non-invertible and invertible functions. So we start with the horizontal line test. Now, if there is a vertical line test to determine if the given equation is a function or not, we also have a horizontal line test that is used to determine if the function is one-to-one or not one-to-one function. Okay, so specifically the theorem states that a function has an inverse function if and only if its graph is cut at most once by any horizontal line. Okay, so using the horizontal line test, we can say that a function has an inverse. And if a function has an inverse, then we can also say that a function is one-to-one. Okay, so for example, we are given a function. This is the graph of the function y is equal to f of x. Okay, then we are given two different values of x, let's say x sub 1 and x sub 2. Then we notice that x sub 1, okay, at x sub 1, we have f of x sub 1, and at x sub 2, we have also f of x sub 2. Notice that f of x sub 1 is not equal to f of x sub 2, given that x sub 1 is not also equal to x sub 2. Okay, so this graph here is an example of a graph of a one-to-one function. Okay, since f of x sub 1 is not equal to f of x sub 2, given that x sub 1 is not equal to x sub 2. And using the horizontal line test, the horizontal line intersects only once, okay, to any part of the graph. Okay, so another example, suppose we have the graph of the given function, y is equal to f of x, and this is the graph. Now, is this one-to-one or not? Or that this function has an inverse? No, this is not a one-to-one function since we're given different x sub 1 and x sub 2, but they're having the same f of x sub 1. So here, f of x sub 1 is equal to f of x sub 2. Therefore, it's not a one-to-one function. Okay? And thus, this function doesn't have an inverse. Okay? So again, using horizontal line test, this horizontal line intersects 2 points on the graph. So it violates the definition or the theorem horizontal line test. Okay, so we have here another example. So suppose we have the graph of y is equal to x cubed. Now, this one, this y is equal to x cubed is a one-to-one function and it has an inverse. Since using the horizontal line test, every horizontal line intersects only one point on the graph. Okay, now again, this is a function, but it's not one-to-one. Now, the function that has an inverse is what we call the invertible function. Okay? Invertible function, a function that has an inverse function. Another example, y is equal to x squared. We know that y is equal to x squared is a function, but this type of function is not a one-to-one function using the horizontal line test because given two different x values, negative 2 and 2, they're having the same f of x, which is equal to 4. So this is not a one-to-one function, though this is a function. And this is not invertible function. So it does not have an inverse function. Okay? Okay, so I have here an exercise. So determine if the graph of the given functions are invertible or not invertible and explain your answer. So if you want to know your answer, if you want to know if your answer is correct or not, You can show your solutions or explanations or your answers in the comment section. So thank you so much. Hope you like this video. Don't forget to share the learning that you've got from this video. Thank you once again and God bless.